In this lesson, I'll show you how to convert a quadratic function in standard form into vertex form. When we say quadratic function in standard form, it is written in the form y equals ax squared plus bx plus c. On the other hand, the vertex form is y equals a times the quantity x minus h squared plus k. Why do we have to know how to convert standard form into vertex form? Actually, the vertex form provides us with more information than the standard form. For example, we can easily identify from the vertex form of a quadratic function the coordinates of its vertex, as well as the equation of the axis of symmetry, because the equation of the axis of symmetry requires only the x-coordinate of the vertex. Now, how do we exactly convert standard form into vertex form? The most commonly used method of converting standard form into vertex form is the method of completing the square. To illustrate the method, let us take y equals x squared plus 6x plus 10 as our first example. The first step in completing the square is to make sure that the leading coefficient is 1. So in this case, the leading coefficient is 1. The next step is to determine the numerical coefficient of the linear term. In this case, the numerical coefficient of the linear term is 6. Now get half of it or divide it by 2 and then square. We get the result 3 squared, which is equal to 9. Now we are going to use this number. We add this one and subtract from the right hand side of the function. What I mean is that we can have y equals x squared plus 6x plus 9 plus 10 minus 9. So it is important to write the plus 9 between the linear term and the original constant, because in this case, we can form a perfect square trinomial. So the first three terms here form a perfect square trinomial, which we can write as a square of a binomial. So we have y equals x plus 3 squared. And then the two constants outside simplifies to 1 or positive 1. So the vertex form of the given function is y equals the quantity x plus 3 squared plus 1. Now, if you want to determine the vertex, you have to be careful in identifying the value of h. I suggest that you write the inner expression using this format, x minus h. So we can write this one as y equals the quantity x minus negative 3 squared plus 1. So now it's very clear that the value of h is negative 3 and the value of k is positive 1. So the vertex of the function is negative 3, 1. Now, if you want to identify or give the equation of the axis of symmetry, you just have to look at the x-coordinate of the vertex. So the axis of symmetry is just x equals the x-coordinate of the vertex, which is negative 3. So this is the equation of the axis of symmetry. Let's have our second example. Let's take y equals 2x squared plus 8x plus 5. Unlike the first example, the leading coefficient in this function is positive 2. But we want the leading coefficient to be positive 1. So let us divide both sides by 2. So if we divide both sides by 2, we cancel the 2 in the leading term and come up with an equivalent function y over 2 equals x squared plus 4x plus 5 over 2. Now we can complete the square. The linear term in the right hand side is 4x, so we take the numerical coefficient positive 4. You divide 4 by 2 and then square. This one is equal to 2 squared, which is equal to 4. Now we will add and subtract 4 from the right hand side. So we have y. So we have y equals y over 2 equals x squared plus 4x plus 4. Again, I will write 4 following 4x. So plus 4 and then plus 5 over 2 and then minus 4. Now, just like before, we form a perfect square trinomial, right? So that's x squared plus 4x plus 4, which we can write as a square of a binomial. So this one is equivalent to y over 2 equals the square of x plus 2. Now let's have the LCD for 5 over 2 and negative 4. The LCD is 2, so we can write this one as 5 over 2 minus 8 over 2. So we have y over 2 equals quantity x plus 2 squared minus negative 3 over 2. Now if you look at this one, the vertex form, the left hand side is y, right? But here we have y over 2, so we have to multiply both sides by 2 to cancel the denominator 2. So we have to copy this one first, and then let's multiply both sides by 2. Alright, so we have to multiply both sides by 2. Now, so we cancel this. So we have y equals, and then you distribute the 2 inside. So we have 2 times the quantity x plus 2 squared minus 2 times 3 halves. And finally, we cancel the 2 here. We have y equals 2 times the quantity x plus 2 squared minus 3. So this is now the vertex form of the given function. Now let's identify the vertex. Again, let us write the inner expression as x minus h. So this one is equivalent to y equals 2 times the quantity x minus negative 2 squared minus 3. So the value of h is negative 2 and the value of k is negative 3. So the vertex is at negative 2, negative 3. And the axis of symmetry is x equals the x coordinate of the vertex. So x equals negative 2. Let's have another example. Let's take y equals negative 4x squared plus 24x minus 8. Like the second example, the leading coefficient here is not positive 1. So let us divide both sides of this by negative 4. So if we do that, we come up with an equivalent quadratic function. So we cancel the negative 4 in the leading term. So we have y over negative 4 equals x squared minus 6x plus 2. Now we can complete the square. The linear term in the right hand side is negative 6x and the numerical coefficient is negative 6. So we will take negative 6, and then divide by 2, and then square. You may or may not include the negative sign because we have to square it, and then at the end the result is positive. So this one is the same as negative 3 squared, which is equal to 9. So I have to add and subtract 9 from the right hand side. So we have y over negative 4 equals x squared minus 6x plus 9 plus 2, and then finally minus 9. And if you look at the first three terms, again, we have a perfect square trinomial, which we can write as a square of a binomial. So we have y over negative 4 equals the square of x minus 3 squared minus 7. Now again, we want y in the left hand side, but here we have y over negative 4. So we have to multiply both sides of this by negative 4 to get rid of the denominator. So let me copy this first. So we have quantity x minus 3 squared minus 7. Now, multiplying both sides by negative 4, so we have here negative 4 times 7. Now we can cancel the negative 4. So we have y equals negative 4 times the quantity x minus 3 squared. And then we have positive 28. So this is now the vertex form of the given function. Now it is clear that the value of h is 3. And the value of k is positive 28. So the vertex is at 3, 28. And the axis of symmetry the equation of the axis of symmetry is x equals positive 3.